To start this problem, let's write out all the connections. So A goes to B and C, B goes to C and D, C goes to D, and D goes to A and B. So if we draw the trees to find all the paths of length 3, we'll find out between which pairs of vertices there are no paths of length 3. So let's start with A. A goes to B and C, B goes to C and D, C goes to D, C goes to D, D goes to A and B, and D goes to A and B. So these are all the paths of length 3 starting at A. So there's one that ends at D, one that ends at A, one that ends at B, and another at A and B, but there are none that end at C. So we know that there is no path between A and C. Now let's do the tree for B. B goes to C and D, C goes to D, D goes to A and B, D goes to A and B, A goes to B and C, B goes to C and D. So now we look at where the paths ended. So you can get to A, you can get to B, you can get to C, and you can get to D. So paths of length 3 exist between B and every other vertex. So now we can make the tree starting at C. So C goes to D, D goes to A and B, A goes to B and C, B goes to C and D. So now we check these paths. So from C you can get to B, you can get to C, and you can get to D, but you can't get to A. So we can say that you can't get from C to A. So now we can check D. So D goes to A and B, A goes to B and C, B goes to C and D, B goes to C and D, C goes to D, C goes to D, and D goes to A and B. So from D you can get to A, B, C, and D. So there's a path of length 3 between D and any other vertex. So the answer to this problem is between A and C, and between C and A.